Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI and the Future of Work. Thanks again for making this one of the most downloaded podcasts about the future of work. If you enjoy what we do, please like, comment, and share in your favorite podcast app, and we'll keep sharing great conversations like the one we have for today. I am your host, Dan Turchin, CEO of PeopleRain, the AI platform for IT and HR employee service. I'm also an investor and advisor to more than 30 AI-first startups and a firm believer in the power of technology to make humans better. If you're passionate about changing the world with AI, or maybe you're just looking for your next adventure, let's talk. We learn from AI thought leaders weekly on this show. And of course, the added bonus is you get one AI fun fact. AI ethicists are increasingly experiencing burnout, according to an article published this week in the MIT Technology Review by Melissa Hekela. Owners of responsible AI initiatives for social media platforms like Meta and Twitter are under intense pressure to stay a step ahead of the potential harm AI can do. Everything from not filtering dangerous content to serving the wrong ads to the wrong users based on AI-driven decisions about, say, age, race, geography, or political affiliation. They get little credit for their advocacy, but significant blame when their initiatives don't perform as expected. Often they're paid less than technical hires with comparable backgrounds, and yet they face more scrutiny when their initiatives don't work. The article that I'll link to in the show notes describes the work of Margaret Mitchell, who left Google, as well as Raman Chaudhary, who, at least as of last week, led or leads machine learning ethics at Twitter. It's a fascinating exploration of the human side of AI ethics, and I hope you enjoy reading the full article. But now shifting to this week's conversation, voice may someday be the predominant computing input. But before it can get there, we need to solve hard technical problems, and many solutions are being accelerated by AI. We've discussed some of these solutions with great guests in the past on this show, like Alex Capistrano, CEO of Josh.ai, as well as Krish Ramaneni, the CEO of Fireflies. Today, we get to learn about on-device voice transcription, a very hard problem that uses an API to do named entity extraction and identify speech attributes like people, dates, and even profanity. It could power an unlimited variety of voice-first apps in areas as diverse as public safety, education, and certainly even entertainment like gaming. Otto Soderlund started Speechly in September of 2018 from his hometown, where he's coming to us from today, of Helsinki. He believes voice should be a first-class citizen for all apps, and making it easy for developers to add voice support from any platform will unlock new innovation. Speechly is a member of the YC Winter 2022 batch. Otto and I recently co-presented at the Voice 22 event in Washington, D.C., although sadly I missed him because I presented remote. So this is the first time we're actually meeting. I heard great things about Otto's talk, and I've really been looking forward to this one. And without further ado, Otto, it really is my pleasure to welcome you to the podcast. Let's get started by maybe having you share a bit more about your background and how you got excited about this space.
Sure. Hey, thanks, Dan, for having me in the show. I'm super excited. So maybe I'll just quickly say a few words about me to just give some context of why would I get so excited about this space. So first of all, I'm a major nerd. I started using computers as a very small kid. I think that I got my first computer at 8 years old. It was a Commodore 64, and I've since been absolutely passionate about computers and all things in technology space. And I've actually also been pretty passionate about artificial intelligence already for over 20 years. I probably originally got excited about it from the computer games I played as a kid, but then I started studying it and I was super into it like 2 decades ago. And back then, machine learning was, let's say, still, being developed. It was early days, there wasn't the flexible cloud computing infrastructures and all the bells and whistles that we nowadays have to build these amazing technologies. But I was still a firm believer that machine learning is definitely the way in the future. Well, I actually did in the meantime step out on a rather different path. So I turned to the dark side, and I did a career in business for some time. I did some management consultancy, started a company, grew it, sold it, and it was only after my old good study buddy Hannes, with whom we were super excited about AI and we were teaching programming at the university, came back. He had been working on the Siri project by Apple, and he had some really good ideas of how the voice technology that was back then available, what were the real limitations of that. So he really got me hooked into voice technology. I've been a big fan of user experiences. I've been a big fan of, novel ways to use innovative technologies. And, it wasn't a very hard sell for my friend to get me super excited about this voice space.
Tell us about a Speechly customer that you're most proud of. How do they use the product?
We have quite a few interesting customers that we are super proud of. We work with many leading brands across a wide range of industries, from retail to media to advertising, entertainment, logistics, and so on. So there's plenty of super exciting customers that I'm very proud of. Unfortunately, most of the let's say sexy brands are the ones that also are the most confidential. So unfortunately, I won't be able to name drop many of our coolest clients from the brand recognition perspective. But to link to the topic of this podcast, there's one particular client that I'm actually really proud of, and that's when we talk about the future of workspace. So the client is called Rain Agency, and it's one of the world's leading conversational and voice AI agencies. And they've recently ventured into building their own voice-powered solutions instead of, in addition to consulting and helping their clients. And as an agency in this space who have been a leader for a long time, they really know voice technology, and they really also understand the end user needs across quite many different industries they work with. And I could say that they are quite an advanced client. And they've actually, I believe it was last week that they first time announced it, came out of stealth mode. And I believe it's actually tomorrow when they're going to officially launch their new voice assistant for automotive technicians. It's called Otto. And it's a pretty cool piece of voice technology. If you look at the problem they're solving, car mechanics, they spend so much time during their working day trying to find information from some of the systems, information about the car parts, spare parts, and they need to record quite a lot of data in the systems. And they do this while they literally have greasy hands. So they aren't able to really, use touchscreens or keyboards. It just isn't really feasible. You need to go wash your hands, and it's, let's say that it's one of the least digitally transformed industries. And why I'm so excited about this use case is that it's actually a very interesting use case because the end user pain is very real. If you talk to car mechanics, they hate technology, and they hate the fact that they need to stop what they're working with their hands and go somewhere to type on some keyboard or touch on some touchscreen. They absolutely hate it. So the pain is really real, but at the same time they do need to find some pieces of information and record some information. So it's a very interesting problem, and the client is very advanced, so they know what they want, and they want the very best. So it's a really good client to work with. And the use case is actually really difficult. You would imagine that it would be a simple thing, but actually the vocabulary that is used here is pretty specific. And the noise levels at the garages, they aren't, your normal office background noises. So I think that it's a very, very interesting use case overall. And overall, I'm very bullish about this whole future of workspace, because if you look at the let's say the history of voice technology, it's been always focusing on B2C, driven by the big tech companies, but there's a lot of opportunity in this B2B side that is totally uncovered. That's why I'm super excited about this example.
I teased in the opener that voice may someday be the predominant computing input. And in an example like you just shared for car mechanics, or maybe even surgeons or who knows, maybe, Uber drivers, there could be a time when their safety is improved and there are a lot of benefits if speech technology or speech recognition, ASR, automated speech recognition technology, was mature enough. Do you envision a time where it's realistic that speech will be the predominant computing input?
Yes, absolutely. But I don't think that voice will completely replace other modalities. I still do believe that there is a lot of usefulness in, for example, screens as a method of transmitting information from the system back to the end user. And a picture is more powerful than 1,000 words. And that's also the case when you're looking at user experiences and user interfaces. So I do absolutely believe that in only a few years' time, voice will become a expected modality in all user interfaces. When you're interfacing with your favorite applications, your favorite websites, your car, your freezer, your whatever piece of technology around you. But it's not in an isolation. It's not on a conversational voice only way, but it's more like if there is a piece of technology, you can interact with it with all the possible modalities available for that piece of technology. So yes, for some lights that don't have a screen, yes, you can use a voice only interface with them. But as soon as you have any other types of ways for the system and the user to interact with each other, absolutely believe that voice will become a central part of that interaction.
So you and I both probably remember a time, maybe a decade ago, not that long ago, when the accuracy benchmark for voice transcription was like 80 to 85%, which means literally out of 100 words, voice transcription will get 15 to 20 wrong, which is almost unusable. And yet today, with the ubiquity of digital assistants in the home and that sort of thing, we see rapid improvements. What would you say is the current state of accuracy or of maturity in terms of voice transcription?
Yeah, I think that's an excellent question. It was actually already, if I recall right, in 2016, when, according to academic research, the human parity was reached. And that was actually already when the seeds for Speechly were planted. The technology has been rapidly advancing. And I would say that today it has reached a superhuman accuracy when it comes to accuracy, also in difficult domains, language domains, also in difficult acoustic environments. If you use models that are built to perform on those difficult environments, those will reach superhuman parity. So currently the state of the industry is such that the technology is already at the sufficient accuracy level to power most of the use cases, because we must remember that human communication is not error-free either. So there is this magical 95% accuracy that is always quoted as the human accuracy level, because humans do make mistakes, and computers will never reach 100% accuracy. That's just not feasible. But they have already now reached an accuracy that is higher for humans. So now the problem is no longer on, is the technology accurate enough? No, the problem nowadays is more on, do we find the use cases that really help us show the real power of this piece of technology, so that we will start to see the real mainstream adoption of value-adding usage rather than fun, gimmicky usage for the technology.
I alluded to a few of the challenges we've talked about in previous episodes on this show of doing voice transcription. It is such a hard problem to solve when you think about, like you said, background noise, accents, all the things that can lead to decreased accuracy. And then I also alluded to something else I know about Speechly, that you're doing a lot of this processing on the device, which opens up enormous new opportunities for innovation. What would you say is the hardest technical problem that you and the team have solved so far?
Yeah, I mean, that's a great question. So I would say that the first and the biggest technical problem that we have solved is that, and that's actually the big key differentiator in the speech technology, is that we have combined speech recognition with natural language understanding, and we've done it in a way that our technology actually does both speech recognition, so pretty much transcribing speech into words in real time, but it also does natural language understanding in real time, meaning that it can understand the user's intents, it can identify different entities that the users are referring to, and it's doing all of this live. Now, if you compare this to the current pretty much state of the industry, where speech recognition and natural language understanding are considered a totally disconnected fields, and if you look at the current biggest voice technology applications out there in the market, how they do is that they process speech in sequential manner, so that the speech is first transcribed into words, sentences, utterances, and these utterances are then, when the user has finished speaking them and the transcript is ready, they are then fed into natural language understanding, where meaning is extracted out of those ones. And this whole sequential processing is the key reason why still today, if you're interacting with your Siri, or if you're interacting with your Alexa or a Google Assistant, the interaction paradigm always works so that you speak and speak and speak and speak and nothing happens. And then when you stop speaking, there is a small silence so that the signal is endpointed, and then the processing can start. And after a few seconds, you actually get a response to your query. And this was the first big technical problem that our team has been solving. So how can we close this loop faster? How can we create technology that allows developers to build really responsive voice-enabled experiences where the system is able to provide some kind of feedback to the user already while they're speaking? Like in a human face-to-face conversation, when we're speaking to each other, it's not like people wait for the other party to finish the sentence before they communicate. People use a lot of nonverbal cues. People are nodding, they're making small sounds, they're smiling, or they can with their facial expressions, they can pretty much communicate whether they're following, whether they're agreeing, whether they're disagreeing, whether they don't understand anything you're saying. And that's a very important part of the why human face-to-face communication is so important. Now, our vision was always that how could we replicate the effectiveness of human face-to-face communication in a human-computer interaction setting? And to do this, we needed to build the technology that is able to both do speech recognition and natural language understanding together. And building a deep neural network that is able to combine those tasks in a streaming manner is something that has not been done before. There is no academic research on that topic. So that actually literally took our team a couple of years of research time, not so much development, mostly research time to figure that out. So that's really the first and the biggest problem that our solved. And the second big problem that we've had to solve is related to being able to provide cloud grade speech recognition on the end user's device. Because normally, if you look at the state of the industry, there has been, on-device speech recognition systems have existed for quite a while, but there has always been this actually pretty massive trade-off between the accuracy of the on-device systems versus the cloud systems. And this trade-off has pretty much limited the usability of those previous generation on-device technologies to very simple use cases. Now, one of the big innovations that our team has had to do, and the hardest problems, was figuring out how can we create cloud-grade speech recognition models that actually can be run with a smaller compute footprint in real time, doing speech recognition and natural language understanding. And I can assure you that is definitely not an easy task. So I couldn't be more proud of our tech guys.
When I was reading up on the technology, I almost thought that I misread it, because everything that we appreciate about the accuracy and the capabilities of traditional digital assistants or the kinds of voice transcription technologies that we're used to, obviously they ship the payload over the cloud, process it using AI and various NLU kinds of techniques. But of course, it has to be done in the cloud because that's where all the training happens and that's where the models live. So my mind is blown. How do you manage to do the training and where do the models live? Because presumably you're needing a lot of fancy AI and NLU techniques to be able to do what you do on a device. I feel like I'm missing something about the architecture.
Yeah, actually, very good point. So to be precise, we do actually do the training in the cloud because training involves such heavy compute that training just one iteration of our model can take many weeks of training with the massive amounts of data that we use for the training. So the training is actually done in the cloud. And we do that so that we leverage, of course, our own training data set, but we also combine customer-specific data to create custom models. And then when we've trained and evaluated and iterated the models so that they perform significantly better than off-the-shelf models, then what we do is that then we ship the models, and we can either ship it together with the on-device SDK, or then we can deliver them through a CDN dynamically, so that the end users can even download the latest models online when a new model is available. So that's the architecture how we do it. So that's the secret for doing that.
Unbelievable. What's the footprint of a typical model on a device?
So we currently have two different sizes of models. We have the full-blown cloud version is 140 megs. That's exactly the same model that we run on our own cloud. And then we have a slightly smaller model for some of our clients who have some very strict size requirements, which is about half of that size.
So we talk a lot on this podcast about the ethical implications of how we store data. Obviously, you and I know all AI comes down to really a data problem and a data hygiene problem. And certainly, requirements so far indicate that's a big component of Speechly. But I think it's important to always ask the question, what could go wrong? So here you are capturing and storing and training on all of this potentially sensitive data that users are providing. What could happen if the AI, the NLU technology is making potentially some inaccurate decisions based on customer data that's been trained on?
Yeah, I mean, I think that's a very fundamental machine learning ethical question, and that is something that is pretty much a very difficult question to answer. Of course, there's been different transparency approaches in trying to give some visibility on the decisions that the AI does, and how that is reflected on our platform. How we try to take that into account is that the configurations we use for our clients, they are all explicit, they are transparent. So that means that it's easy to see what is the configuration that is being implemented. So of course there is the signal processing black box of machine learning, but the NLU configurations and the adaptations, all of that is something that can be transparently assessed, what it has been trained for. So that brings a level of transparency to the models. And of course, we try to be very careful with the training data that we use, of course, respecting the privacy and anonymity of pretty much the sources of that data. But the truth is that there is no silver bullet for ensuring that a machine learning system wouldn't do unethical decisions. The thing is that the machine learning system does not know the difference between ethical and unethical. They only know the difference between what is their input data and what they have been trained for to deliver in the output layers of the neural network. So I think that the only ways to address this with current technology, and to my knowledge, are transparency and then ensuring the consistency of those models so that they always produce the same results with the same inputs. And those are the principles that we have been using when designing our technology.
I was thinking of two specific examples, and I'd love your feedback about to what extent Speechly takes responsibility in either of these cases? Let's say maybe they seem kind of innocuous, but you could envision these could be potentially harmful. A false negative, where let's say there's some profanity, and the named entity extraction model misses it, and some kind of a speech agent and app built in Speechly ends up spewing hateful things like the Microsoft Taybot. There's one example where potentially Speechly could have a role. And then a second one, what if, again, named entity extraction, potentially an address might be misinterpreted. So detects that there's an address being provided, and maybe, let's say, my Uber driver gets sent into, a bad neighborhood, or, gets taken, to a place where I never intended because Speechly maybe misinterpreted the address. Both cases where, certainly it's the result of maybe, an incorrect automated decision from Speechly. What responsibility does Speechly have in those cases?
I think that's an excellent question, especially using those examples. So I love the utilization of the examples. I'll first start with the Uber one. So the design philosophy that we have developed together with our technology is that for the use cases, like, for example, capturing some information like an address from the user, our recommendation would always be that there would be when the modality is available, there would be a visual confirmation to the user. So how we would recommend our clients designing that address capturing use case would be so that the address would be shown to the user visually, so that they could confirm that, so that they wouldn't be surprised when they arrive to a totally different place. So that would be how our design philosophy would take that into account. As again, for a machine learning system, there is no such thing as 100% accuracy, meaning that there will always be edge cases. And then the question of responsibility is quite an interesting one, which is a good bridge to the other example that you shared about this, let's say the kind of like not being able to detect a profanity. So that's something that is a case that is happening currently with our clients who are using Speechly to detect profanities and other types of hateful behavior, because even though our technology is significantly more accurate than anything else on the market, it still isn't 100% accurate, and it never will be. And the fact is that machine learning systems work so that they pretty much mimic the data, the behavior of the data that they have been trained on. And for example, a named entity recognition task requires training data, and the training data is generated by human annotators, and human annotators aren't 100% accurate. They oftentimes disagree when different annotators are annotating the exactly same case. They disagree. And when we're talking about, profanities are pretty straightforward, but like hate speech or misinformation or child sexual molestation, sometimes, it's not so straightforward. You need to understand a little bit, the context for that. So that means that even humans cannot perform that task well. So that means that it would be impossible for us to give 100% accuracy guarantee. So instead, what we try to do is that we build this feedback loop into our solutions. So we regularly, with our clients, we create these feedback loops where the clients share with us some pieces of data that has been manually annotated, keep monitoring the performance of the system, and keep learning and ensuring that the system is all the time up to date. So that's for these let's say subjective tasks. For you to be able to build a robust system, some kind of human in the loop approach is something that you need to be able to feed your machine learning models with high quality training data, so that they can adapt and become better all the time.
Let's fast forward a decade in the future. You gave that great example about the car mechanics and the rain agency. I love that one. What's another thing that's a task that we currently do in some kind of manual fashion, but in 10 years, it will just be commonplace that we do it using some kind of automated speech recognition technology?
So I would even turn that the other way around. 10 years, a decade is a very long time. I'm very bullish on voice technologies, not only on the B2C side, but especially actually on the B2B side, on the professional side. So much of time spent by all different kinds of professions, whatever their industry is, after digital transformation goes to actually interfacing with all different kinds of systems. The classical examples are, of course, doctors who spend most of their time interfacing with the computer rather than the patients, and so on and so on. So in 10 years' time, it will be so normal that everybody will be using voice technology as the main interface to their professional and personal technology surrounding them, that pretty much we don't even think about voice technology as anything separate. It's just a user interface. It's so ubiquitous that we don't even think about it at all. So I think that's the thing. So it's if I turn it around, where would we not use voice technology? Only things I could, it's very hard for me to imagine. Only things are when there is something, when you are in a place where there's lots of other people and you are processing something that is sensitive. I would say that that's probably the only place where you wouldn't be using voice technology. Otherwise, you will be using it everywhere. So this would be my prediction. And voice technology as a separate field will not exist. So everybody working in this field, including us, we will be pretty much jobless because the industry has already merged into the overall technological evolution, that it's not a separate vertical anymore.
That's a bold vision. So maybe it won't be the predominant computing input, but it will be a first-class citizen alongside other modalities.
Yes, exactly. And it will be a expected modality and a preferred modality, but other modalities are good in other things. And the best user interfaces are really the combinations of leveraging the strengths of the different modalities, bringing them together and solving the end user's tasks as effectively and efficiently as possible. And that's really by bringing voice into that mix of modalities that designers, developers can use to solve the end user's problem, that will really bring the next leap of productivity and actually also intuitiveness in human-computer interfaces. And that's what we are super excited about.
Otto, I know the time flew by, but we're about out of time. And I'm not going to let you get off the hot seat without answering one last question for me. So in over 150 episodes, you're the first guest we've had from Finland. And I'd like to know, what are the advantages and maybe disadvantages of building a tech-first company outside of a traditional tech hub?
Yeah, that's actually a great question. So, well, first of all, Finland is not one of the big tech hubs, but it's not a medieval society. We have had our Nokias and several big gaming companies and other very interesting tech companies have come from this space, and especially the engineering scene in Finland is very, very good. And actually, we have an unfair advantage being located here because the access to really world-class engineering talent with reasonable prices compared to, for example, the Silicon Valley prices, that's something that is really, really good and powerful advantage for us. That being said, of course, our main target market and all of our major clients are in the US. So in the commercial side, it's of course a bit more tricky to build and run a company from Europe targeting the US markets. But luckily, COVID has made it a bit easier to build new business using video call. And of course, especially after COVID, people do appreciate when people come physically to meet them. So by flying where the clients are often enough, that helps bridge the invisible gap of location when working from Finland.
Well, the Finnish government should hire you to promote high-tech jobs migrating over to Helsinki. That was a very good answer.
You are all engineers are very welcome to Helsinki. There is a lot of very interesting work here.
Excellent. Well, Otto, we're out of time, but where can the audience learn more about you and the work of Speechly?
I would recommend you to check out the Speechly website at www.speechly.com. There's a lot of interesting demos that I would encourage everybody to check out. It's a bit different take to the voice technology that people have used to seeing. So please check out some of the demos and get inspired. There's also access to our developer tooling, so it's free to register. So all the developers, designers out there, feel free to register to our tool. We have a free tier up to 50 hours per month of free usage for non-commercial use. Feel free to use it as much as you want and share with me all the cool stuff that you're building with it. And of course, feel free to follow us in Twitter, LinkedIn, and so on. And you can reach me at otto@speechly.com.
Beautiful. Otto, well, when your vision for the future of speech recognition comes to fruition, maybe you'll come back and hang out with us again.
Absolutely. I hope before that.
You bet. Well, this has been so much fun. Really enjoyed learning more and appreciate you hanging out.
Thanks, Dan. Same. It was a pleasure. Thanks for having me.
Well, that's all the time we have for this week on AI and the Future of Work. I'm your host, Dan Turch, and of course, we'll be back next week with another fascinating guest.